Okay, so I tend to use those things all the time. Like you guys remember using the frogs at one point and all that kind of stuff. And kids always struggle with which way they should pull it back, right? And so I want to know, does one do a better job with accuracy? Now, like I said, you guys will get to pick between doing means versus doing proportions. How do we decide if we're going to do something with X bar versus something with P hat? What type of variable it is. So for this particular variable, they flung them at this little target and we recorded, was it a hit or a miss? So between hit and miss, is that quantitative or categorical? Categorical. It is categorical. Okay. And knowing that my two variables are categorical, what am I going to do? I'm going to have P hats, okay? Is everybody with me on that? Okay, so now let's say the variable you're interested in investigating is quantitative. If that's the route you go, okay, then you're going to be doing X bars, and you'll also need to get the standard deviations, okay? How do we find the mean and the standard deviation of a data set? We haven't done it in a while. I've usually given it to you, but if you gather your own data, you're going to have to find it, okay? So if you decide to go that way, you would use your one variable stats to get there. Is that everybody good? Yeah. All right. Now, guys, some of you have a tendency on your projects to just copy verbatim and just change the numbers around. If you write both of those things down on your project, you will get 0 credit from that for that question. Do you guys all understand what I am saying here? Okay, I'm not giving you credit for just copying and changing numbers around. I want you to be thinking about which one applies to the project that you are going to do. So you shouldn't, everything I write down here should not be in your project. Like, you need to be able to distinguish which one's which. I'm going to try to color code it for you. Cool? All right. Now, the next thing you're going to do is gather your samples. So for the dominant hand, and this was, for the dominant hand, guys, that we used which hand they pulled back with. Okay? So I'm going to say the dominant pullback was 10 hits, 23 misses. And the non-dominant is 10 hits, 14 misses. Obviously, if your variable's quantitative, that'll look different, yeah? It'll be a list of numbers. All right, now, how many do you think you should have to gather? The answer is, depends. You want to know why? The whole point of our sample size is making sure that normal condition is met. Okay, so if, for your P hats, if you're doing something with P hats, you need at least 10 successes and 10 failures for each group, for each sample. Do I have at least 10 successes and 10 failures for the dominant hand? At least 10 successes and 10 failures for the non-dominant hand. You guys with me now? For X bars, how many do you think you need? What's the normal rule for X bars?
30.
30. It should be 30 of each. I'm going to say 20 of each. Okay? Because that's starting to get, 30 of each is starting to get to be, I think, an unmanageable thing depending on what you're doing. So as long as you have at least 20 of each, you're fine. But that's each sample. So for instance, let's go ahead. Logan, can I steal yours real quick? Mm-hmm. Logan is researching different types of engines, diesel versus non-diesel, is that right?
Yes.
And then looking at fuel economy. So he might have 20 diesel cars with diesel engines and 20 cars with gas engines. But I think you have more than that, right?
Yeah.
Does that make sense? If you wanted to do like a certain, like a sports analogy or something, if you wanted to do, or let's say you're doing Minecraft versus, I don't know, what other games do you guys play?
Fortnite.
Minecraft versus Fortnite?
Roblox. Elden Ring.
Is there something comparable, like you score points in each or something?
Terraria.
No.
Minecraft and Terraria are pretty comparable.
You don't score points.
Well, you don't score points in Minecraft.
Well, that's what I'm saying.
Like, okay, I was trying to be relevant to what you guys find interesting, and I just don't know enough about it to like make it actually sound like a cool example. Let's say you're looking at your phone and you're looking at your heart rate for two different types of exercise, or you guys get what I'm saying? Okay. You know what I think would be really interesting is, though it would be hard to find it now backwards, the screen time on block days, like even days versus odd days, which one do you have more screen time on? I think that would be kind of interesting. I wish you could like limit screen time to like certain classes, because that would be very intuitive and like a great way to reflect on, I don't know. Anyway, what I'm trying to point out is there's lots of different approaches we can take to this, okay? So you don't have to go ask 30 people from 30 underclassmen, 30 upperclassmen if you don't want to. There's stuff you could find where there's already data out there, okay? So I'm just thinking of some of the different data points I keep on my phone at any given moment. And there's lots of fun, interesting things you might be able to find where you can compare two populations. It doesn't have to be two populations of people. Like, for example, this one is two populations of aiming a dart. You guys see what I'm saying? Okay? All right. So, moving forward, we then have to say, what is our statistic? So, in this case, my statistic is going to be the p hat from the non-dominant hand minus the p hat from the dominant hand. You could do that the other way around. It doesn't really matter. So, for the dominant hand, or for the non-dominant hand, they hit 10 out of 24 times. For the dominant hand, they hit 10 out of 33 times. And then you got to figure out what that is.
Was it 23 or 33?
33.
You said 23 earlier.
Sorry. I got 0.1136.
Wait, so should we change this to 33?
No.
No, it's 23 misses, but that's a total of 33 trials, yes?
Right, sorry.
And a total of 24 trials?
Yeah, never
No,
mind.
that's my bad. Like, this whole point is I'm supposed to be explaining this to you, right? And guys, if this were means, this statistic would be X bar from your first group minus X bar from your second group, okay? You would just find the two means and subtract the difference. All right. Then you're going to find your critical value. And I'm going to, this time we're doing 90%. And if my middle is 0.9, what does that make my tail?
0.05 for each.
0.05 for each, okay? And notice that this is a Z star because it is proportions, right? So you can just do inverse norm to find it. So guys, help me out. What is the inverse norm of 0.05?
That's minus 1.644. 1.645.
It is probably 645. How would this differ if it was means? We wouldn't be finding Z star, would we? We would find T star instead. Okay. And for T star, we have degrees of freedom, which is n minus 1. Which sample would I use in that case? Because you have two n's, right? One for each group. You pick the smaller sample. Okay. And then do inverse T. All right. To find the margin of error, you're going to take that Z star times your standard deviation, which in this case is, we should do this. It's a rough life she lives. I'm going to let you guys write that down and make sense of it before I move on. I'll be right back. Because you're going to have to, find your own standard deviations. So any question where any of these pieces came from? At this point, hopefully it's becoming a little bit second nature to you. And did anybody figure out what this was for me? No? Well, I didn't give you the explicit direction, so I don't think I can get that mad at you. And technically, this is my project, so I should do it. I got 0.211. Everybody good? Okay. Hey, what would it look like if it was means? It would be T star plus or minus T star times. Your formula would be S squared from your first group over the sample size, S squared from your second group over the sample size. And then you would add those two things together, take the square root, okay? So it's a slightly different formula when it's means. Is everybody feeling okay? By the way, where do we get that S? From those one variable stats up top, okay? It'll still be there. You just have to do the one variable stats twice, once for each group. All right? To get your interval, you're going to take your estimate or your statistic. So our statistic was 0.1136 plus or minus your margin of error. And I got negative 0.0974. And 3 0.3246. So guys, you tell me, does my interval suggest there's a difference between my two populations?
It's because there's a negative in the interval.
It's not just because there's a negative. It's technically not the negative, though it kind of relates. Because if both ends of the interval were negative, then it would be okay.
Is it that zeros in the interval?
Yeah. So because zero's in the interval, then it's always 0. We can't say, I would like you to do this in, there's a difference between left and right-handed.
Left and right or dominant, non-dominant?
Yeah, probably better. Dominant, non-dominant. Get over it. Are you talking yet?
Oh yeah, I've been talking. I actually started talking 30 seconds after that class went out because I realized I would have to order food. So.
And then you just threw it out, the whole thing out the window?
Yeah. I did
Instead
do
of just-
self-reflecting.
Instead of just, Oh, you mean at the... Did you go to a drive-thru or something?
No, we went to Dunkin'. I was put in the mood for more donuts by having a donut.
Understood.
And I'm still mad that John took the only jelly filled right before.
I had to be the one. I'm a jelly donut girl through and through.
There's a jelly filled? Can I take it?
Yes, I don't want it. I want this out of my room.
So,
I want it out of my room. You guys aren't mad. Get over it.
I'm not mad.
You want to lick the icing off the
I'm
box?
just disappointed.
I'm not gonna-
With my start.
He says as he grabs the box. If I had a spoon. I don't have a spoon. I'm not gonna get a spoon.
Okay.
Oh. It just fell somewhere. Oh, okay.
All right, is everybody good? We're at the first page? Okay. All right. Minus or non-dominant minus? I did non-dominant. 0.113. 0.41. 0 was inside this interval. Does that make sense? Okay. So I will then, now we're going to write some hypotheses. Our null hypothesis is going to be that the P from the dominant, did I do dominant minus? Non-dominant minus dominant equals 0. My alternative is going to be that it is greater than 0. A reminder that our P hat N minus P hat D from the first page was 6. Everybody good? All right. So then my test statistic will be a Z statistic. We're going to divide by that standard deviation again, which was 7. And it's the exact same standard deviation formula from the previous page. We went straight to the margin of error. If you just found it separate and then used it twice, that would be fine. Guys, and I found that Z statistic to be 0.884. Okay. Yours is gonna be whatever you find it to be, right? Okay. How would this change if this was an X bar example? Well, the top would be your X bar A minus X bar B. Just like we use P hat N minus P hat D. And our standard deviation formula is gonna be SA squared over NA, SB squared over NB. Okay. P-value. If you're doing Z's, it will be normal CDF. If you're doing X bars, it'll be TCDF. And your DF is going to be N-1 using the smaller sample. Same idea. Plan it in shade. Plot it in shade, yeah? So if I go in and do my normal CDF, I'm finding my p-value to be 0.884. The answer to the p-value is 0.188. Okay, according to my sample, is there a difference? A significant difference? Can we rule out our H0?
Yes.
How do we decide?
Because it's greater than or equal to 0.05.
Since our sample is reasonably likely.
What do we say our samples are?
Sample. Since our blank is, I didn't say anything, samples are reasonably likely. We cannot rule out H0 and cannot say there is a difference. And then I'm just going to do a little bit more context because this is the whole point of this is context. Difference in accuracy between dominant and non-dominant hands. Now, the goal of this project in my head is that you guys are practicing both of these skills, tests and intervals. However, ways you can check yourself on your work is they should both come to the same conclusion as either there is a difference or there is not a difference. Okay, so like I knew that this was going to be a high p-value the minute